Welcome back to Hands-On with Reinforcement Learning. In this section, we're going to talk about the multi-armed bandit. The multi-armed bandit, as we said before, is a simple environment where we understand exactly what's going on in an environment that lets us really drill down to the agent side of the loop in the reinforcement learning paradigm. In this section, we're going to take a look at three things. Number one is creating a bandit with 4 arms using Python, Numpy, and then we also understand how multi-armed bandits relate to the CardsPro environment. So as I said, MAB is, you can kind of think of it as like a simple environment that dumbs down the CardsPro environment, because if you can recall, in CardsPro, there's a lot of information. The environment gives you 4 numbers that really doesn't mean anything unless you dig into the physics of it. Whereas in MABs, because you wrote the whole environment yourself, and the environment itself is very, very simple, it's very easy for you to grasp what's going on within the environment. And then it allows you to focus on how to create an agent that actually finds the optimal action in this environment. Number 2, as I said from number 1, is from this environment, we're then going to talk about how we can create an agent from scratch, i.e. without using any sort of smart searching algorithms that you would see in textbooks, but more kind of really drilling into what policy search looks like. How do you create an agent that finds the right policy to solve the environments, in this case, the multi-armed bandit problem. And then in the last part, we're going to put this together and we're going to train the agent so that it goes through many, many experiences or loops of the MAB environment. And then we can see at the end that this agent is actually trained to perform the right action given the MAB's settings. Great. So we've done a homework in creating, so let's get to it. In this video, creating a bandit with 4 arms using Python and Numpy and understanding how MABs relate to CardsPro. Very simple, like it says on the tin. We're going to create a bandit with 4 arms using Python and Numpy, and we're going to understand how MABs relate to CardsPro v0. Let's talk about multi-armed bandit. Multi-armed bandit is one of the simplest environments you can encounter in reinforcement learning, and it's actually a great way for you to understand what is an environment and how are rewards generated in an environment, so that it builds upon your understanding of how environment and reward then affect how you select a good strategy. So what is a multi-armed bandit? So a multi-armed bandit evolves from the term one-armed bandit, which is a colloquial term to describe a slot machine. So in a slot machine, you have an arm where you pull, and then you either win, in which case your reward is, let's say, $1,000, or you don't win, and then your reward is -$1, or whatever cost you incur to get that one slot machine to work once. So in a multi-armed bandit setting, the problem is the following. Imagine if you have multiple slot machines, each with a different probability of rewarding you that $1,000. Now, you have a trade-off. You can either stay on one machine and get a better estimate of how frequently this machine pays out, or you can veer away and explore a different machine and see, you can chance upon a machine that pays out more frequently. So in reinforcement learning literature, this is called the exploration-exploitation trade-off. What we're doing here is we're going to implement our own environment, much like the CardsPro environment that we've been playing with so far, that allows us to simulate a multi-armed bandit situation. So the first thing we're going to do is, in the multi-armed bandit class, let's initialize all the bandits and their payout probabilities. So here I have a bandit with 4 arms, and each arm has a different propensity to pay out, right? So in this array, you can see that there are 4 different numbers, and the way we're going to affect the rates of payouts is we're going to generate a random number every time somebody pulls the lever, and if that random number is higher than the current arms bandit level, then the reward would be 1. Otherwise, the reward would be -1. So as you can see that the higher the level, or the higher the parameter for that arm, the less probable that something would pay out. So in this setting, in this multi-arm bandit setting, the 4th arm here is the most likely to pay out because it's the lowest threshold, so it's easiest to generate a random number that is larger than 4. And so to keep track of things, we can also put in a numActions parameter so that we can use it later. And we also need a pull function where it indicates that you pull the multi-arm bandit environment, and you provide it with a variable of arm, which is which arm you want to pull. So as we described before, we're going to generate a random number using the normal distribution, and we're going to see whether this number is higher than whatever arms parameter is specified by the inputs into this function. Let's see whether this works. We're now back at our terminal in our Python environment where I have loaded the script from before, and let's initialize one of the multi-arm bandit environments, and then let's try to pull a random arm. Let's say the first arm, and then we'll pull it again. As expected, sometimes the reward for pulling the first arm is -1, and sometimes the reward for pulling the second arm is +1. As an exercise, what you can do is to pull different arms for, let's say, 1,000 or 10,000 times, tally up the probability of generating a positive reward, and actually going back to look at your settings to see whether, given the way that we've generated a random number out of a normal distribution and comparing it to the thresholds of different arms of the multi-arm bandit environment, actually prove it to yourself that you have implemented the multi-arm bandit environments correctly. I also want to pull your attention towards a particular feature. So I've purposefully named our multi-arm bandit object as env, much like would have done if this environment was within OpenAI Gym. The second thing that you would notice is actually env.pull, which is a function named according to how a multi-arm bandit works, is actually the same thing as env.step in the cartpo environments that we've looked at in the previous videos. Here, instead of going left or right, you have a choice of actually 4 actions. You can pull arms 1, 2, 3, or 4. And each of the different pulls would give you a reward, and unlike the cartpo, it wouldn't give you a state. So this is actually a simpler environment versus when compared to cartpo, because you don't need to care about whether the state affects the reward of your actions. All you need to care about is which arm to pull, how often do they generate a positive reward, and then figure out eventually the best arm to pull all the time. Great. So we have created the environment in Python. So now the next thing for us to do is to go on the other side of the reinforcement learning loop and talk about creating an agent that could solve the MAB environment. See you next time.